Hello my friends, welcome to Habasha In this video tutorial, we are going to study about basic continuous time signals. Let's get started. So, basic continuous time signal. The objective of this video tutorial is to simulate the basic continuous time signals in MATLAB. So, after completion of this YouTube video tutorial, the learner knows about how to represent basic continuous time signal graphically, how to represent continuous time signal mathematically, and how to simulate these continuous time signals using MATLAB. Continuous time signals that vary continuously over time and can take any value within a certain range. Continuous time signals are continuous both in amplitude as well as time, and they'll take finite value in a certain range, and they can be represented mathematically using certain continuous function. Part 1. Now let's simulate basic continuous time signal using user-defined function. The first signal is the unit step signal. The unit step signal u of t is defined as 1 for t greater than or equal to 0, and it is 0 for t less than 0. Graphically, just we can represent unit step signal like this. So it is 1 for t greater than or equal to 0, and 0 for t less than 0. The second basic continuous time signal is delta of t. Delta of t is defined as mathematically, it is 1 for t is equal to 0 and 0 otherwise. Graphically, just we can represent delta of t like this. So it is 1 at t is equal to 0 and 0 for all other values of t. The third signal is tri of t, the triangular signal. Tri of t is defined as 1 minus absolute value of t for absolute value of t less than or equal to 1 and is 0 otherwise. Graphically, we can represent triangular signal like this, and is in between -1 and 1 is 1 minus absolute value of t and 0 for all other values of t. The fourth type of basic continuous time signal is rectangular signal or rect of t. Mathematically, we can define rect of t as it's equal to 1 for absolute value of t is less than or equal to 0.5 and 0 otherwise. Graphically, we can represent rect of t as 1 between -0.5 and 0.5, and it is 0 for all other values of t. The fifth continuous time signal is signum of t. Signum of t is defined as 1 for t greater than or equal to 0 and -1 for t less than 0. Graphically, we can represent signum of t as 1 for t greater than or equal to 0 and is -1 for t less than 0. And the sixth basic continuous time signal is ramp signal, r of t. R of t is equal to t for t greater than or equal to 0 and 0 for t less than 0. Or just we can define r of t as t times u of t. Graphically, we can represent r of t like this. It is t for t greater than 0 and 0 for t less than 0. And the next one is sinusoidal. This is not a user-defined function, but it is predefined function. Y of t is equal to sine of omega t. Graphically, we can represent the sinusoidal signal like this, where omega is equal to 2 pi divided by t, where t is the period. The next one is sinc function. Sinc of t is defined as sine of omega t divided by omega, where omega is equal to 2 pi divided by t, where t is the period. And graphically, we can represent sinc function. Now the second part is continuous time signal simulation using built-in MATLAB functions or predefined MATLAB functions. Let's get started. Square of t, y of t equals square 2 times pi times f times t, where f is the fundamental frequency. And this is the square wave representation. And here f is equal to 0.5. And the next one is exponential signal. Y is equal to e the power of minus at, where a is an element of real number. So graphically, we can represent e the power of minus at, where a is greater than 0 and it is a decreasing function. And if a is less than 0, it is an increasing function. And the other type of signal which is predefined is Heaviside of t. This Heaviside of t is the unit step signal. Heaviside of t equals 1 for t greater than or equal to 0, and it is 0 for t less than 0. And Heaviside of t equals u of t. It is equal to 1 for t greater than 0, 0 for t less than 0. The next one is rectangular signal or rect pulse of t is defined as is a predefined MATLAB function and is equal to 1 for absolute value of t is less than 0.5 and 0 otherwise. So graphically we can represent like this. Rect of t equals 1 between minus 0.5 and 0.5 and 0 for all other values of t. And tri of t, the triangular pulse, that is tri-pulse, is 1 between minus 0.5 and 0.5 and 0 for all other values of t. And we can increase the width. The default value is between minus 0.5 and 0.5, but it's possible to increase the width of this tri of t between minus 1 and 1. Function definition for unit impulse or delta of t. Function y is equal to delta of t. Y is the output argument, delta is function name, and t is the input argument. Y is equal to t equal 0. If the value of t is equal to 0, or if this test condition is true, then the value assigned for y is 1. If this test condition is false, then the value assigned for y is 0. Function definition for unit step signal u of t. U of t is equal to 1 for t greater than or equal to 0, and it is 0 for t less than 0. So the keyword function y is equal to u of t, where u is function name and t is argument. Now let's go to the function body. Y is equal to t greater than or equal to 0. If the value of t is greater than or equal to 0, or if this test condition is true, the value assigned for y is 1. But if this test condition is false, then the value assigned for y is 0. End of the program, end of the function. Function definition for ramp signal r of t. R of t is equal to t for t greater than or equal to 0 and 0 otherwise. Or just you can define r of t as t times u of t. So function dot the keyword function y is equal to r of t, where y is output argument, r is the function name, and t is the input argument. Y is equal to t dot times of t. This is a function body. So function definition for triangular signal, tri of t. Tri of t is defined as 1 minus absolute value of t for minus 1 less than or equal to t is less than or equal to 1, and it is 0 otherwise. So the keyword function y, which is output argument, tri function name, and t is argument. Y is equal to 1 minus absolute value of t for minus 1 less than or equal to t and t is less than or equal to 1. And for all other values it will be 0. Function definition for continuous time rectangular signal, rect of t. Rect of t is defined as 1 for minus 0.5 less than or equal to t is less than or equal to 0.5. Or rect of t is equal to 1 for absolute value of t is less than or equal to 0.5. So the keyword function, the output argument y, rect, which is function name, and the input argument t. Y is equal to absolute value of t is less than or equal to 0.5. Function definition for sinc of t. Function y is equal to sinc of t. T, where t is a period, is equal to input enter the period t. Omega is equal to 2 times pi divided by t. Y is equal to sine of omega t dot divided by omega t. Now here, the program will run based on the user selection. Now enter your choice, display unistep for unistep signals, delta. If the user selects delta, then it will display delta direct signal. If the user selects triangular, then it will display tri-opti, and it goes like this. So y equals input, enter your choice, and the choice is string. So consider that the user has selected unit step. Then y is equal to u of t. This is a function calling part. Plot t comma y. Red color. The line width is 3. And title unit step signal u of t. And x label time index. And y label is amplitude. If the user selects delta, y is equal to delta of t. This is a function calling part. Plot t comma y. Red color. The line width is 3. And the title is unit impulse signal. Delta of t. X label time index. Y label is the amplitude grid on, hold on. And if you select triangular, then y is equal to tri of t. This is function calling part. And plot t comma y, red color, and this is 3. And the title is triangular signal, lambda t. Y label is amplitude, x label time index, grid on, hold on. Now, if you select rectangular, the function calling part is y is equal to rect of t, plot t comma y, red color, line width is 3. The title is rectangular signal, rect of t, x label, time index, y label is the amplitude. If you select signum, this is the function calling part, y is equal to signum of t, plot t comma y, red color, line width is 3, and the title is signum function, signum of t. And if you select ramp, y is equal to r of t is a function calling part, plot t comma y, red color, the line width is 3, and title is ramp signal r of t, color, red color, font size is 35, and the font name is Tahoma. X label, time index, and y label is the amplitude, grid on, axis tight, and hold on. If you select sine, then input the period for sinusoidal signal, omega, which is equal to 2 pi divided by t, and y is equal to sine of omega t, plot t comma y, red color, line which is 3, and the title is sinusoidal signal sine omega t, and x label is time index, y label is amplitude. The next one is sync, y is equal to sync of t. This is a function calling part. Plot t comma y, red color, the line is 3. The title is sync function, sync of t, and the font size is 35. X label, time index, and y label is the amplitude. And the next one is square function. Input, enter the frequency of the wave, and then y is equal to square 2 pi f times t. Plot t comma y, red color, the line is 3. The title is square wave. So the next one is sawtools. Enter the fundamental frequency, y is equal to sawtools into 2 times pi times f times t, where sawtools is the built-in MATLAB function. Plot t comma y, blue color, the line is 3. The title is sawtools waveform, and the font size is 34. The color is red, and font name is Tahoma. X label, time index, y label is amplitude, axis tight, grid on, hold on. The next waveform is exponential. Enter the value of a, and then y is equal to e raised to minus at. Plot t comma y, red color, the line is 3, and the title is exponential signal is a power of minus at, and the color red, font size is 35, font name is Tahoma. X label, time index, y label is amplitude, axis tight, grid on, hold on. Now let's proceed to the built-in MATLAB functions. The first one is heavy side of t, and this one will help us to simulate the unit step signal. Y is equal to heavy side of t, plot t comma y, red color, line which is 3. Title, unit step signal, heavy side of t. The y level is amplitude and x level is time index. Axis type, read on, hold on. Case rect pulse. This one will help us to plot rectangular signal. Y is equal to rect pulse of t, plot t comma y, plot t comma y, red color. Line width is 3. Title is rectangular signal, rect pulse of t, y level, amplitude, and x level is time index. Grid on, hold on, the axis is time. And the last one is triangular pulse, tripulse, which is a predefined function. Y is equal to tripulse of t, plot t comma y, red color, line width is 3. Title, triangular signal, tripulse of t, x level, time index, y level is amplitude. Grid on, hold on. So we have finished this one and save this file with file name CT, and then go to command window, write CT. So enter your choice, unit step for unit step signal, delta for delta direct signal, and then triangular for tri of t. So just you continue like this. Let me start with unit step. Unit step. So the graph for unit step is like this. It is 1 for t greater than or equal to 0 and 0 for t less than 0. And now let's consider another case. Let me consider the case for triangular signal, tri of t. So just call with CT and then enter your choice. Triangle. So this will plot the triangular signal tri of t. So you can continue for all other signals. Now let's consider heavy side. The case for heavy side. Heavy side. This is a plot for heavy side of t, and this one for t greater than 0 and 0 for t less than 0.